Hi guys, this is Mrs. Gassler, and in this video we're going to talk through how to work with slope and graph. This is the worksheet called Slope Practice 1. You can find it on page 27 of your handy packet. And we're just going to walk through this together. So let's see. We got Jamie. Jamie's marking the position of a traveling toy car as the clock ticks. And this is the data that Jamie has. So we're going to make a graph of position versus time for this car. We're going to put time on the x-axis in seconds, and we're going to put position on the y-axis, and that looks like it's marked in centimeters. Centimeters, seconds right there. I just used an abbreviation there. It looks like I go from 0 to 9, so I'm going to mark that on here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I go from 2 to 20, and I've got 10 boxes, so I'll go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This one's going to be kind of easy, isn't it? All right, except at 0, it's at 2 centimeters. At 1, it's at 4 centimeters. At 2, it's at 6 centimeters. 3, it's at 8. 4, it's at 10. 5 is at 12, 6 is at 14, 7 is at 16, 8 is at 18, and 9 is at 20. So there is my beautiful thing. Now I'm going to draw a best fit line. Best fit line means I'm just going to I'm not connecting the dots, I'm just drawing a line where they are. Now those dots all connect, so it kind of is like connecting the dots, but it's a best fit line, okay? All right, now if you still need to finish that, pause the video and finish that first, okay? All right, so let's answer these questions here. What is the position of the car at 3 seconds and 5 seconds? Well, I can look over here or I can look at the graph, but I need to find 3 seconds and note what the position was. So at 3 seconds, it was at 8 centimeters. And at 5 seconds, it was at 12 centimeters. And the question says, how far did the car travel from 3 to 5 seconds? Well, if it started at 8 and it got to 12, that is a distance of 4 centimeters. From 8 to 12 is 4 centimeters. Okay. What do I think the difference between position and distance is? Well, let's see. Position is where it is, and distance is how far it goes. And we talked about position and distance and displacement already, so hopefully those are pretty easy things for you to think about. How long did the car travel? And this is like the total time, because it's not saying from 3 to 5 seconds or anything like that. And I started at 0 and I went to 9, so that was a total of 9 seconds. 9 seconds are shown on my graph here. And the vertical intercept, that's the up and down part. Okay, so where in the intercept is where it runs into the axis. Okay, so I'm looking for right here. Where is it on this line? It's at 2. The y-intercept is at 2 centimeters, and it says, what do I think this means? Well, what do you think it means? I'll tell you what it really means. That's just where it is when it starts. That's where the car started. At the y-intercept, time is 0. Okay, time is 0, so that's the start. So it just started at the 2 centimeter mark. Okay. Now if you flip over, there's a few more questions for us to do here, and so we're going to be calculating the slope. Okay. This is what I do here, and we're going to follow these rules here. So we're going to find the slope of each of these lines. And we're going to use some units to think about what that's going to be on there. So first we're going to pick 2 points. I like to pick points where it crosses. Like if you see down here on this one, this is not a good point to pick. Neither is that one or that one or that one. That one's okay. So I'm going to pick my 2 points. I'm going to pick that one and this one. Doesn't matter which ones you pick. You could pick different ones. That's okay. And then I'm going to draw my triangle. So there's my run and there's my rise. If you really wanted, you could draw this triangle instead. Totally up to you. Either way, it's going to be the same thing, but when you find the rise, don't go by boxes, okay? Don't write boxes. Yes, it's 2 boxes by 2 boxes, so the rise is 1, but that doesn't tell me anything because that's not what is being measured on the axis here. So my rise is the going up, so I'll make a little arrow for you. Rise is going up. So I started at 20 and I ended at 60, so my rise is 40. And then my unit is meters, so my rise is 40 meters. Okay, so there's my unit that I put on my answer there. Now my run goes this way, And oh, I picked, let's see, that's 10 and 20, so this must be 5 and 15, right? All right, so I started at 5 and I ended at 15, so my run is 10, and then I need a unit, and that's seconds. So when I'm trying to find the slope, it's rise over run. It's always rise over run. So I'm going to stick 40 on top and 10 on the bottom, rise over run. 40 divided by 10 is 4. And then for my unit, I just take this and stick it right there, meters per second. And so that is my answer. Now meters per second, that's a speed. So the slope of this line is the speed. How interesting. Now it looks like this one might be going slower, but it might actually be going faster because it's got a different number here. These axes are a little bit different, so I'm going to do the same thing. I'm going to pick 2 points. This one is a good one because it doesn't touch there or there or there or there, but here it does. All right. So let's see, I went from 0 to 300, so my rise is 300 and my unit is meters. And my run is from 0 to 10, so that's 10 and that's minutes, okay? So I have 300 meters in 10 minutes. When I do the math there, 300 divided by 10 is 30, and then my unit is just meters per minute. So there's my slope on that one. This one is in fact going faster, even though it looks lower, but the numbers on the axes aren't the same, so it can't be compared. I can't compare those two, and I can't compare this one either. All right, so here I can pick a whole bunch of different points. Let's go with some easy ones. How about this one and this one? So my rise is 200 centimeters. My unit is right there. And my run is 20 seconds. Oh, good. I'm so glad I was able to do these without a calculator. But I could use a calculator, and you can too if you need to. The rise goes on top, so that's the 200 centimeters, and the run goes on bottom, that's the 20 seconds. So let's see, when I divide these, 200 divided by 20, that's not, let's see, there's 5, 20, so that's 10. 10 centimeters per second. And that is the answer there to that slope. Okay. Now, if you are done with that, make sure if you need to stop to pause anything and go back over that, that's fine. The next thing I want you to work on is slope practice 2. So you're going to do the same kind of thing where we plot what we're doing. Slightly different questions. It's going to ask you where it's at different times and then the distance that it travels. And then it's going to ask you a couple of other questions here, which we'll talk about. And then there's some more practice of just finding the slope on the back side here. Remember, you need to pick dots where it crosses. That helps you get a much better answer than just picking any old random dot. All right, so now I do want you to turn in this slope practice 1. These are kind of your notes here for drawing and answering questions about how to find slopes. So make sure you turn in both the front and the back of this slope practice 1 and then work on slope practice 2. Thanks for watching.